southern dynasties. In Sieve province lived a judge so wise. Yang Jin was his name, a man of sharp mind. When justice was needed, his wit would shine. A merchant came riding, robbed of all he owned. No local tongue, no local clothes the stranger shone. He told the judge a robber's face and dress with care. Yang Jin listened close, then hatched a plan right there. Oh, the trap was set with a mother's broken cry, a false corpse by the gate beneath the open sky. Who will claim the body? Let the guilty run and hide. But a mother's love will lead the judge right to their side. Spread the word, he ordered, a voice both stern and calm. A man lies murdered outside the city wall. His clothes and features mark them well, good folk. Come claim your kin before the evening smoke. The news flew fast like swallows on the wind. Soon an old woman came, her tears would not end. Wailing loud, she begged to see the one they'd found. Yang Jin watched her closely, every word profound. He questioned her gently on the smallest detail, the color of the robe, the pattern on the veil. Every answer matched the merchant's tale so true. The judge smiled softly, he knew just what to do. Go hide outside her house, he told his trusted men. Wait for the robber when he comes home again. The sun was setting when the suspect crossed the door. They seized him in an instant, he could run no more. They searched his room and person, every hidden place. Found the merchant's treasures, every coin and case. The robber's face turned pale, his courage quickly fled. He knelt before the judge and all his guilt confessed. Oh, the trap was set with a mother's broken cry, a false corpse by the gate beneath the open sky. Who will claim the body? Let the guilty run and hide. But a mother's love will lead the judge right to their side. So sing of Judge Yang Jin, whose wisdom never failed. He solved the crime with heart and cunning, not with sword or jail. In troubled times when darkness tried to steal the light, one clever mind brought justice in the dead of night.
In the business realm, a prime illustration of this is how major tech platforms interact with third-party developers, a practice often referred to as platform rug pulling or Sherlocking. A notable case study is Apple and an app named FlickTwist, although this scenario occurs frequently throughout the tech industry. Startups and independent developers create applications that address gaps in significant ecosystems like Apple's App Store or Google Play. The platform owner supports these developers by providing tools and APIs to help them create their products, enhancing the overall value of the ecosystem. As developers progress, they invest their own resources and time to demonstrate that there is a substantial market for a particular feature. Once the developer has reached the pinnacle and shown that the market is quite profitable, the platform owner intervenes. They incorporate the identical feature directly into their operating system at no cost, effectively eliminating the developer's access to the customer base and severing their path to success. In the realm of video games, players often embrace this strategy both literally and metaphorically, but the most renowned and iconic instance is found in the Sims franchise by EA. In this game, you take charge of virtual characters and shape their lives. For many years, gamers have employed a notorious trick where they persuade a Sim to take a dip in a backyard pool. The Sim eagerly descends the ladder into the water, fully engaging in the fun. Once the Sim is joyfully swimming, the player switches to build mode and removes the pool ladder entirely. Since earlier versions of the game did not permit Sims to exit over the pool's flat edge, the Sim becomes trapped in the water with no way out. They would swim around until they eventually tire and drown. Even as the game progressed, this became the quintessential gaming meme for ensnaring an unsuspecting character by eliminating their sole escape route. Use tricks and traps to draw your opponent into dangerous territory, then sever his means of communication and escape routes. To survive, he will have to contend with both your troops and the forces of nature. The ancient strategy of removing the ladder once the enemy has climbed to the roof focuses on trapping and containing them. You entice the opponent into a vulnerable position, block their escape routes, isolate them, and eliminate the threat. When we relate this to the realm of deepfakes, particularly the alarming types that target children, like AI-generated child sexual abuse material or extortionate deepfakes, the enemy is the synthetic media payload and its distribution network. The roof represents the public domain or communication platforms. By utilizing this approach, we can develop the ladder cut framework, which stands for leveraging automated deepfake defense via explainable reasoning and containing underlying threats. The ladder cut architecture consists of 4 main technical layers. First up is the trapper, which employs cross-modal deepfake detection. Rather than depending on single-frame analysis, the front end utilizes cutting-edge multimodal pipelines to identify structural weaknesses in the enemy's presentation. Spatial temporal relation modules, including modified efficient-net pipelines, examine intraframe texture irregularities, such as unusual blending around the eyes and mouth, as well as interframe temporal artifacts like inconsistent eye blinking rates or microjitters. Phase-aware audio verification assesses phase discrepancies and acoustic environment patterns instead of merely focusing on raw audio magnitude, comparing the speaker's vocal track against established genuine basslines. Cross-modal graph attention networks depict audio and video segments as nodes within a heterogeneous graph, highlighting the unnatural synchronization when a child's lip movements fail to mathematically align with the audio phase shifts. The second component is the anchor, which employs knowledge graphs to establish provenance and context. The knowledge graph serves as the foundational truth matrix, linking contextual metadata to detect identity theft or conceptual distortions. Each public figure or protected demographic profile, including children safeguarded under localized protective identity vaults, is represented as nodes. Contextual validation highlights logical discrepancies, such as when a deepfake attempts to portray a child in an unrealistic setting where the relationship between the entity's location and reality does not match. Graph embeddings create structural representations of the relationships between real and fake content, enabling the system to query the graph and verify if the semantic context corresponds with reality or known clusters of deepfake distribution when a suspicious file is identified. The third component is the Sieve, which employs small language models. Rather than relying on slow large language models at the edge, localized small language models that have been optimized through quantization serve as real-time context engines. They conduct behavioral assessment by analyzing textual metadata, transcripts, and the context provided by community flagging surrounding the media. For speed and edge deployment, these models operate natively on consumer devices or edge routing nodes, enabling them to perform immediate linguistic risk scoring, such as identifying extortion patterns or linguistic manipulation tactics commonly used to spread child-targeted deepfakes. This process calculates a threat score, where the overall risk is determined by the weighted sum of visual artifacts, audio phase mismatches, and the risk score from the small language model. The fourth element is the ladder cutter, powered by explainable AI. When you block content without understanding, the adversary can adapt by discovering the reasons behind the ladder's failure. Explainable AI serves as the tactical executor that mathematically confirms the anomaly and permanently closes the vulnerability. Agency AM and Grad Cam++ ensure that rather than a black box decision, the system identifies the specific pixel clusters, like edge blending around the jawline or unusual lighting gradients on the skin, that triggered the classification. Shapley values measure the precise contribution of each feature, including visual, audio, and textual context, to the identification of deepfakes. Lastly, automated reason generation creates a cryptographic report that is understandable by both humans and machines, detailing exactly why the media is synthetic. To illustrate the workings of the ladder-cut framework in a practical context, we can examine incident 1348 from the AI incident database. In this instance, 8th grade boys at Mountain View Middle School in Goffstown, New Hampshire, utilized an AI-powered application to produce and share sexualized deepfake images and videos of their female classmates. If a communication or social media platform were to implement our flat ladder-cut algorithm, the defense strategy against this incident would unfold in 5 distinct operational phases. Initially, in the multimodal ingestion phase, the malicious actor tries to upload deepfake media aimed at a classmate. The platform's front-end spatial-temporal relation modules analyze the file and identify structural irregularities. It recognizes inconsistencies in the texture around the jaw and eyes, where the victim's face has been artificially merged onto an explicit model's body. The system flags these subtle jitters and artifacts, resulting in a high visual risk score. Second, the contextual screening phase activates simultaneously. The local small language model examines account behavior, metadata, and the accompanying text captions. It recognizes toxic, non-consensual language patterns and connects them to group chats or profiles featuring several student names. At the same time, the system queries the secure knowledge graph. The graph reveals that the face belongs to a child entity registered in a protective localization vault, but the location, contextual tags, and digital origin signatures of the video are in significant conflict with the child's true identity nodes. The cross-modal network calculates a troubling threat metric that rapidly exceeds the automated intervention threshold. Thirdly, the entrapment layer employs a bait and roof strategy. Rather than simply rejecting the file with a typical failure error message, which would alert the student that the app's filter has detected them, prompting them to re-edit or compress the image to evade detection, the algorithm discreetly redirects the payload. To the uploader, the progress bar reaches 100%, indicating a successful upload. However, the file is actually sent to a secure mirror sandbox that is entirely disconnected from the public internet and invisible to any genuine users. The threat remains contained on the roof. Fourth, the explainable AI forensics engine starts examining the asset it contains. It utilizes IGEN-CAM and GradCAM++ to create visual heat maps that highlight the exact pixel clusters where blending took place. It computes Shapley values to assess the contributing factors, mathematically confirming that the image is synthetic. The system then automatically generates a clear forensic report detailing the exact reasoning behind this conclusion. Fifth, the system retracts the ladder to effectively neutralize the threat. While the asset remains harmless in the sandbox, the engine creates a cryptographic perceptual hash derived from the combined visual and contextual data. This distinctive hash signature is promptly shared with global protective registries to ensure the asset cannot be uploaded elsewhere on the internet. At the same time, the platform undermines the source by permanently revoking the uploader's account tokens, blocking their device signatures, and documenting the cryptographic forensic report for school administrators and law enforcement officials adhering to the youth justice guidelines. The malicious actor is entirely contained and disconnected, unable to weaponize or redirect the media. You need to elevate the expectations you have for your opponents, pushing them to extend their efforts and resources, forcing them out of their comfort zone and into a more challenging environment. Present enticing advantages to your rival that are hard for them to refuse, and that encourage them to reveal themselves, allowing you to take action.